Welcome to the channel. Today we are going to make an accessory for our soldering iron that I've been wanting to do for a long time. So before we get started, to give a little backstory, this is my soldering station. It's the WLC 100. This is the Weller brand. It's pretty much the go-to for anyone who's been doing soldering for a long time, and this was the standard up until about 15-20 years ago. The TS 100, which is a quick heat DC powered soldering iron, came on the market. I always wanted one, but I really couldn't justify getting it because I had this great unit. The only problem I don't like about this one, it just takes forever to heat up, and then I lose my motivation for soldering if I don't have that instant gratification of heating it up. So I didn't get the TS 100, but when I saw this is the Pinecil. This is another, it's based off the TS 100, but the one addition it has, as you can see, is it has a DC and a USB-C connector. So right now I'm powering that Pinecil up to the wall with USB-C. No problem, it heats up in 8 seconds. If you want to see a video of our initial review of this, I'll have a link in the description below. But the whole point of this is to be able to take it around with you and have it mobile. So that is where the DC barrel port comes in. I want to take my tools, which I use Makita mostly in the shops, battery system, and power the Pinecil so that I can be remote and still be able to solder wires without having to be close to any outlet, which is the negative to this. You always had to be plugged in and it was slow. And with that, so you can use the Pinecil either one, but you're still connected to the wall. So by being able to use the 18-volt battery system, I can be out in the field or anywhere without having to needing a wall outlet to power the Pinecil. So to get that, we just got these adapters. These have become very common now for any battery system, I think. Before it was just DeWalt, but now pretty much everyone who has a power wheel and they want to convert their power wheels for the kids to 18-volt batteries, I think they pretty much, the Chinese market has knocked off all these adapters for every type of battery system there is. So this was only like $3. And then that would be fine, but I wanted, just to be fancy, this is a volt and amp meter, and I want to add it to it. Now this is going to be version 1, and it's not going to be pretty because there's not enough space in here to add the display nicely recessed. It's going to be sticking out a little bit like that, so it's going to be kind of bulky a little bit, but I want to have it because I want to watch to make sure that we don't drain the battery too low below its desired levels. So let's get started. So if you're interested in any of the items we use today, I will have a link to the Amazon pages down in the video description below, so just take a look there. For this volt and amp meter, I've tested it and it works very well, but there is no documentation that comes with it. You'll see in the Amazon listing, the reviews, people complain because if you wire this wrong, it will fry it. And really, since there's a bunch of wires, people really didn't know what to do with it. So I found online a nice little diagram to use, and everything is at your fingertips with the web. But what I'm going to, the reason there's two diagrams here is, one, if you have a separate battery source for the display, it can run off DC 4 volts to 30 volts. This is the way you want to do it. But because we are going to run off the actual battery, we're going to have our own battery source here, then we are going to just run off that battery source. So we're going to be using this side of it right here. So for this display, you've got two sets of wires. This detects voltage, this detects amperage, and powers the unit. So these are the smaller 3 wires, this is the thicker wires. People are having problems because they were connecting the voltage side of it to the power side, and that will fry it. So make sure in the circuit that you connect the voltage side of the display to the negative side. Now, because we're using our own power, we do not need to use the ground of the black of the smaller wire, so you can just cut that off or just leave that off. That's not going to be used. So for the smaller wires, we're going to get power for the display on the little red wire, and it's going to go out the ground this direction. But the yellow wire that we have, that's where it detects amperage, and it needs to be in parallel to the actual circuit. So you see how it goes from here in parallel and then down, whereas voltage needs to break the actual circuit up. So you see how the negative is broken, and so this is in series, so it goes up, detect voltage, and then comes back down and then recycles back through. So that's kind of why you need two separate sets of wires. So this is the battery adapter. Now there is 6 screws. The plate is made of 2 pieces, and what holds the bottom of the plate to the top of the plate is 4 screws right here, which I already took out. And there's 2 more screws, but that actually holds the connectors, which we'll get into when we open it up. So let's go ahead and open it up. And so those 2 screws that I talked about just holds the connectors in place right there. So you don't really need to take that off unless you're actually doing something with the connectors itself. What I am going to do is, I think we're going to drill 2 holes, 1 small hole to send the power and the amp line through, and it's going to connect directly to the red. So let's drill some holes here for the wires to run through. Now to make things easier, I'm going to go ahead and disconnect these wires so they'll be out of our way here. So I'm going to work on the amp side of it. So what we'll do is we'll stick all these wires down in here. I'm going to leave them long. I know I'm going to regret leaving them long, but we'll leave it like that. The black one I'll probably tape, but we need to connect these red and yellow wires to the power wire here like that. So let me cut a little bit off of here, off the red wire, and then we can solder that together. Now we just need to wrap the red and yellow together, and it will go like that. So then we just need to wrap the red and yellow on the red here, and we'll solder it up just like that. We're going to use our Pinecil to make an attachment for our Pinecil, but we're going to use the USB port for this one. We'll connect that up, and then we'll plug this in to power source. Also, the benefit of having the Pinecil in such a small, compact packaging, that I can keep all my soldering gear and the Pinecil and the power supply in one little box. Whereas with the Weller, you'd have a lot of material, a lot of things to carry, so it took a bigger box. So let's get our solder out. We might not need our helping hands, but this is a little helping hands I've created. It's just a piece of wire with 2 alligator clips, so it helps me solder sometimes, but I think we'll be alright. We won't need it today. Alright, so here's our Pinecil. We push the plus button, and it's set up for left-handers, so it's going to run up the power to, I think it's set for 350 degrees Celsius, and we're talking it's like 8 seconds. Yep, 350. So now it's just going back and forth. It's heated up. So look at that. I can just get started on the project, and I don't have to wait for the soldering station to heat up. So let's go ahead and heat the wire up here. Get a little bit more on the bottom. Get it all the way around so we got a good nice connection there. So you can place your soldering iron and it'll sense that it's not been used in a few minutes, and it will start to cool down to safe temperatures. So you don't need, and then there's also a setting too that will turn off completely like in 10 minutes if it hasn't been used. So I like that, so you can never forget it. It's smart enough to know to turn itself off. So there you have everything soldered together, and we're going to tape it up just for strength and so there's no shorting. I've come to find out over the years that there is a difference between electrical tapes. This is 3M's 33 plus, I think it's the plus or just the 33, but you can feel the difference when you're peeling it than if you just get a roll from the dollar store or something that's real cheap, you can tell a difference. So I tend to, even though it's $6 a roll for the 3M stuff, it's worth it. So I am going to put a little bit more on the wire, and what that does is help for strain relief, so it doesn't get pulled out. So there you go. So hopefully that's going to be thin enough for us. Now what we need to do is we've got to run the black wire up through the hole. Oops. Let's see here, the wire is getting all messed up there. Back up through the hole here. And we will make our connection outside. To the wiring harness here. I was going to put a connector on the negative here, but it's going to be bulky enough out here. I wanted to try to clean it up a little bit, so I'm going to extend the wire. That's probably as far as, if I ever need to take it apart again, that's as far as I need to pull the wire out because of the amp line. And so what I'm going to do is we'll just cut the connector a little shorter, and then we're going to just splice it together and just leave it like that. I think that'd be a little bit cleaner and a little nicer because it's going to be about right here. So let's even, it's going to be like that. Yeah, let's cut this line right here. Oh no, just before we do that, that's not the line we want to do. We want to do the positive line here. So let's cut it short right about like that. Alright, and we're going to trim it. The only thing about these, I like them, but you have to hold them right-handed. Since I'm left-handed, you just kind of, because you can't use your left hand because you can't see it, so you always got to have it in your right hand. I'm always, since left-handed, tending to pick it up with my other hand there. There's some other ones that go straight on that can be used either way, but I don't have those. So what we're going to do is we're going to trim this down a little bit. So we took the black line, untwisted it to spread the lines apart. Also did that on the other side too. And then what we're going to do, alright, I don't know if you caught me on that. I stopped mid-thought because I would double-check with the diagram and I was making a mistake. We should be going from the power line, which is what we're working on here, should be going to the negative line of the meter, and then the red goes out to the load. So I almost wired it backwards, which might probably not been good, or maybe giving us a negative value or blowing it up, I'm not sure, but we do need to do the other direction. So that's not a problem, we can fix that, and we will go ahead and hardwire the negative side, and then I'll put a connector right here. This will be a connector, so that if we do need to take it apart, we can easily do that. So let's cut the negative side, and I am going to make that just a little bit different, longer. And again, we got to be this on the right side. And the reason I do that is I like the ends to be staggered. I don't like them all to be at the same height, just in case if there's a short and this eats through the tape or whatever connector, it doesn't have anything to touch. Whereas if it was down here, they could accidentally touch like that. So let's get back to it. So from the battery, we're going to go to the negative of the meter. I knew you guys were yelling at the screen that I was doing it backwards, but we'll get there eventually. So you see how I'm splicing the wires intertwined, and then we're going to give it a little twist so they kind of lock to each other. This way it's giving a little bit of a physical connection in addition to the soldering, which is our mechanical connection. As long as we're doing the soldering. I wonder if soldering's, I guess it's mechanical, it's not chemical too. This is where the helping hands help out. And just make sure they don't pull your part. That's the only problem, is they tend to pull the piece away from each other. Let's try that again. There you go. Get a nice connection. Alright. Now you see the Pinecil went to sleep because it was sitting for that long, so it's off right now. So I need to push power, and it's starting back from 0, and it's heating back up. So we'll just give that 8 seconds. Now give me enough time to find my solder. Heat up the wire. Nice solder connection there. And flip it over to make sure we got enough on the back side. We'll get our helping hands off and get some tape here. So for the negative side of the load, we are going to use this little piece of wire, and since we're going to be running it through the base through 2 different holes like that, I'm going to use a connector. So if I need to take it apart, we've got a male and female connector, and they're protected with a plastic sheath around it. So we're going to use that to make our connections. We'll just stick the female here on. Let's cut it down just a little bit, it's a little long. And then we will crimp it. Give it the pull test here. So that's on that side. That's the female. I'd like to double check, and that's the male. So we're going to probably cut this end down a little bit also. It's a little too long. And we'll crimp that also here. Give it a little pull test. Make sure they connect. Oh, we bent the connector a little bit. Let me get a screwdriver. The connector inside got a little bit bent downward, so we're gonna just bend that back up. There we go. We can connect it. Nice, good connection. Now we need to send the wire through the body and then out through the front. This is where we're going to connect the load to it. And the wire is just a bit too thick for it, so we're going to have to drill the hole out just a little bit. I think the black wire is a 14 gauge rather than the smaller gauge wires that came with it. Send that through there. Send the red wire back through. So after getting the wires connected, I just taped up that black wire that goes on the amp side of the display. Just taped it up so it doesn't short out anywhere, and we're going to jam it in there. And then everything is wired correctly through here. So let's get it put back together. We'll first attach the connectors with the connecting screws if we don't lose them here. Fall out everywhere. Alright, nice and tight. We'll slide this all together. It slides in, jam it in there, kinda. Not much room. You want to make sure all the wires get in there. Let's make sure these wires are not too jammed up. I think that'll do it. I think we do. Oh yeah, we're good. Alright, let's get the screws in the four corners and then we'll test it. Now the screws that hold the two pieces together does take a T10 star bit, so just be aware of that. Whereas the other one was just Phillips. So we'll get all four of those in. Alright, let's get the multimeter out and we can test our connections. So the first thing we're going to do is let's set on a DC volts. We're going to test the battery just to see where we're at. That's positive and negative. Let's see, I'm not getting a good connection there. There you go, 19.57 volts. So that's good. We are going to connect our battery adapter to our battery. And then let's connect our sensor here, or not sensor, our display. $19.6, so it rounds up in 0 amps. So that's working. So let's check the ends here. Oh, I've got to strip one end here. This is what I'm talking about. Now I got to do it right-handed. That's what I keep. That's the problem I have with this one. So we got negative. And we got positive. Can you see? $19.57, perfect. We got great power coming out. So everything's hooked up properly on this side of it. So let's get some connectors on here and I'll show you how we're going to connect it up to the Pinecil. So from the battery, again, we're going to stagger the connectors just so that they aren't close to each other when we are plugging it in, or if there's a cut in the wires, they don't short out as easily. Another good practice is to stagger the connectors. So if we're going to put a male on the red line, the power, you want to put a female on the negative. So whoever's using this can never mess up too bad, at least when they're connecting it. That is going to be the opposite connectors on each line. So because if you do both males on each line here, male on this one and a male on this one, and then someone goes to connect it up, they can connect it up backwards, so you don't want to do that. So just to make it easier, there's a male on that side and the female on this side. So we will go ahead and connect those up, and that is how we are going to connect it to our line. And I do want to make this be able to disconnect easily, just for if we have an issue with the line that we're going to use. You can always change it out later. Perfect. Now for the other end, so this takes a DC barrel connector. It's called 5525, which I think means 5.5 millimeters tall and 2.5 millimeters in diameter there. So that's the or maybe that's 55 this way and 2.5 that way. Well, either way, it's a DC connector. It's 55-25. I have to look it up. So I took this off of an old laptop AC adapter and just cut the DC part of it off. Strip some of the wires back, and that is what we're going to use to connect the other side. Now, to make sure that we are connecting the correct side, you want the negative to be on the outside of the barrel and the positive to be on the inside of the barrel. That's specified in the Pinecil instructions. So the way to figure that out is you do some continuity testing. So you get your multimeter back out, turn it to the sound sign. That's continuity. So when you touch, it makes a noise and lets you know that the circuit is being completed. So now you don't know which is positive and which is negative. So you hold one end on one wire. So we're going to do it on the outside of the wire. And the other end, we're going to connect it to the outside. If it beeps, that means there's a continuity. And that means the negative is the outside wire. And the internal wire here is positive. You got to stick it down inside. And that's positive. Now if I connect it here, there is no beeping because it's two separate wires and it's not connected. So for the negative, we've got our black is the female, so I need the male side for the negative connector. And for the positive side, will be the opposite. There's male on that end, so we need the female on this end here. A little pull. It's tight. Probably need to get a little bit better connector on that, but we will tape that up for strength. Let's double check. We got negative going there and negative here. Perfect. And this is the male and female side. So there you go. We'll connect it up and give the Pinecil a test. There. And the connector is a little bent there. Perfect. So now we can connect the battery to it. So it's showing 19.6 volts. The reason, again, on the voltage, we don't want to get too low. These Makita batteries don't want to go below 16 volts, or it will hurt the internals of it. So that's why I kind of want to watch it. So now we will put the meter on volts DC, negative to negative, positive to positive on the inside. And we're getting 19.57 volts, which is the correct voltage. Perfect. So now all we need to do is connect it to our Pinecil. And we do need to change the setting here to power source from DC. DC was when it was plugged in to the wall. We're going to change it to, I think it's 5 cell. There's 5 cells in the battery here, so we can go from there. So 5S is 5 cells. And let's get back to the beginning. Power it up. Let's watch it. It'll give it 8 seconds to get to 350 degrees. And there we have, we got smoke coming out. Take a little bit of solder, and it is heating up. So this does have a battery meter on here, but the software is set for, I think, 10 volts, 12 volts cutoff. I think you have to, I haven't been able to figure out how to change that unless you actually plug this up to the computer and reset it. I could reset it to 16 to protect the battery, but since I haven't learned how to hook this up to the computer and play with the settings that way, we're just going to have to leave it as using our voltmeter here, or display, and you can see the amperage changing. I'm not really concerned with amperage, I just thought it was kind of cool to kind of watch that. But we want to stay above 16 volts down here, which is plenty of power for keeping our Pinecil going. So just to give you kind of a bird's eye view of what we got here is now we are no longer connected to mains power. We are just connected to battery powered, so we can carry this wherever we want to go and we can solder. Now I will figure a way to connect this. I'll probably just glue it to the case, the display to the case, kind of like that for now. I don't really have a good answer unless we 3D print something for it, but there wasn't any room to really stick that in there. But other than that, it's usable. Sometimes it's function over fashion, and I'm happy with it, and we are good to go. So with a little bit of CA glue to hold the display down, a little black duct tape to kind of hide the wires back there, and a little bit of electrical tape to decrease the stress points on the wire, and especially here too, so it doesn't, because it was very flimsy with the wires connecting right there. So a little electrical tape there. We now have our portable soldering station that we can go wherever we want. So now that I'm mobile, I have no excuse to ever not solder something or just use butt joints by itself. So I hope this inspires you. If you're interested in any of the items we used today, look down in the video description. And if you'd like to see more videos like the one that you just saw, you can check here and here. And remember the ABCs of making. Always be creating. Till next time.